So the purpose of my talk today is to give you a kind of experience report. Just the problems we encountered, to describe them a little bit and to see what we have done. So it's what was the contents of my talk. So what is a CMS? The history of the CMS used in the Geneva Museum. Then the Specify 6 CMS, Collection Management System, CMS. Then what we did to migrate all our data, to collect our data, to aggregate our data in one single system. So the migration of our legacy data and a little bit also the conclusions. So what is a CMS? So for natural history collections, it's a software solution that permits museum curators primarily to do the following tasks. This is to get an inventory of all the collection objects in a museum or in a more restricted collection, to know where these objects are stored so that you can find them again, but also to document the history of the object and also, more and more important, the acquisition and identification of the object. It's especially the aspect of acquisition. Was the object legally acquired? It's something you have to prove more and more. But the CMS should also be able to manage loans of objects. It should be able to print labels. And, especially nowadays, it should be able to store and manage digital photos. So all these aspects, they are centered on the management of the collection itself. So these are more the desires of the curator. But the collection management systems should also be able to facilitate at least, or to provide some kind of data exchange module, and also ideally to give some possibility to create your own web page, some museum web page, that people can search for certain objects or for objects they are interested in, would like to borrow. So the history of the CMS used in the Geneva Museum in 1990, about a few of our curators started to create their own CMS solutions. So some of them, they took the Excel, if that existed already, but there were other similar solutions. But most of them used the application FileMaker, which was very basic in the 90s, very simple application, but it was, I think, the best thing you could get at that time. Not all of the curators were able to create their own databases. Some had their databases or their applications or solutions designed by external enterprises. But also these, let's say, the own constructions and also the ones that were created by outsiders, they lacked actually generally a correct underlying data model, which should be used for a collection management system. So in short, the construction of the databases lacked professionality. So they were created for the use of the curator itself. So it was not really thought that maybe in 20 years, other aspects will be much more important. So data sharing and all this, nobody thought of this. But because of the lack of professionality and controls, so there was a very low degree of control, and also the quality of the data was not good at all. So we have numerous spelling errors. There was an uncontrolled usage of geographical and taxonomical classification. So the same name was used in different spellings and different languages and abbreviations. And especially also the abbreviations were a problem, but many of the users, they used abbreviations that were only intelligible to them. Only they knew what it meant. And other users, they couldn't make up what it was. And they never thought that they would be replaced someday. So when the curators left or when they were retired, then we were left with data which were not interpretable. So sometimes we had to ask them, what does this mean, this abbreviation? And so this is not a good practice. Here, this is a more modern version of a FileMaker application, but which also lacked the necessary controls. And the result was actually a kind of evolution. So there was one curator who first started it with the FileMaker solution. The others thought, oh, that looks good. Please give me a copy. They took a copy of the database and they started to modify it according to their needs. And so in the end, we had about 14 different databases which had quite diverged from each other. Some used still the same names for the same property, the same type of information, but it was not very well comparable. And especially also for the geology here, they were completely separate. They had a completely different system. So in 2017, the museum made an internal audit, and we concluded that the situation did not meet the criteria of a serious and especially a sustainable collection management system, or actually also a collection management for its own. There were about 14 databases, and at all there were about 500,000 objects recorded in them. During this, or as a conclusion of this audit we compared several possible CMS systems available on the market. There are not many at all. Some of them were extremely expensive. Some of them were not really useful for us for natural history. And in the end, we decided that Specify might be the best thing for us. So actually, we decided to introduce Specify, to migrate all our data to this application. Specify 6 in this case, is an open source client application, so that you have your program on your computer, but it uses in the background, or it accesses, it stores its data in a standard MySQL type database engine. So that's, for those who are not familiar with this is actually about the industrial standard for a database, MySQL. So that's all the professional database engineers, they use it. Or at least there are several types of it, but it's quite a generic thing. The development of Specify is actually managed or made by a consortium of the United States. It was based at Kansas University, but so it's open office. It's an open application which you can download and install as you like, but then you are left at your own. So if you want to get help, and if you want to have something to say in the consortium, you have to pay, and then you can also influence the decision they made, so how it should get developed. The underlying data model, so how the data are organized in Specify, is quite exemplary for managing natural history specimens of biological origin. That includes also paleontology. And I would like to present it here in a simplified form. Specify uses a relational database. That means many tables that are linked, something that our old FileMaker databases were only very rudimentary. So this was not, relational database was actually not available in FileMaker. It was only introduced in the late 90s or 2000. So a relational database is based on different linked tables, which reduces the redundancy of the data. So you do not always enter the same name again in a field. So here a kind of organizational schema. You have actually the central or the core table for the natural history database, which is the collection object table. In this table, so you have the catalog number, the field number, entry book number, all these numbers and characteristics that are direct, that identify an object. The other data are all or mostly linked in external tables so that they can be reused. Let's say you have collectors for an object. You can have one or two or several. So this is also a linked table. And the link is actually made via another table that acts like an address book where there is only one instance for one name. So when you change the name here, then it's modified in the whole database. But this also offers to add numbers like this ORCID number or anything other biographic information. So it's all centralized, and there's only one instance for one type of information. You have determinations, identifications of the object for zoological objects. And also here you have a kind of taxonomic thesaurus where you get your information from, and also these taxonomic names, they're only stored at one place. They are not always retyped in. And an important structural element in the CMS is also that if you have an object, it can be composed of several preparations. So you have a kind of a mammal. It has several preparations. It can have a skeleton. It can have a skin. It can have slides. It can have DNA preparations and all this. So you have several preparations, and it's actually the preparations that are loaned. It's not the object itself. So an object is composed of several preparations. In most cases, of course, like for entomology, it's just one preparation. It's a pinned insect. So the collection object and the preparation is identical. The user interface had to be modified so extensively as the default one was not suitable for us. So the user interface you get when you download it from the Specify webpage was not usable. And I would like to show you an example for the invertebrate collection, how we restructured that. And also the structure you see, it reflects to a certain degree, actually, the relational database structure. So you have some complex steering buttons and all this. I do not like to go into the details. The information is here in these white fields, and I think it's very difficult to show. So there are some kind of separators, and they basically correspond. So these are kind of tabs, and they correspond to linked table. So what we have here, yeah, a little bit. So you have the catalog number, you have the acquisition data, which is actually a summary. So these are aggregated data. I will come back to that later. You have the taxonomic determination, and actually several could be possible. You have here a kind of counter. You can have an illimited number of determinations. You have the locality data, where it was collected, which is also a summary. You have, this is special for the invertebrate database. You have a host determination and also links to other collections like mammals and fish. Here you have the preparations, which are in a table view. And in this case, you see here, you have 4 preparations. There are actually 3 tubes with DNA stored, frozen, and 1 alcohol as a voucher specimen. Just when you click on one of those aggregated fields, it will open a floating window with more detailed information. So in this case, it's the locality name, then the geographic information, latitude, longitude, and all other information. Especially important is how the georeferencing was made. So what's the precision of the latitude, longitude, how this was obtained, and how the accuracy of this. The same, if you click on one of those preparations, you get the floating window that opens where you can either modify or read more data for this thing. On the right panel, we have the photos. We have object data, so which are mostly numeric data or data like sex or age. We have the citations, the references, where the object was cited. Especially important for type is here, you give the first, so the original publication for the type specimen. We have a large field for remarks, which is expandable. And here a button for DNA data. In this case, so you see this number 6, that means we have actually 6 linked DNA sequences with this object. If you click on it, it opens a simple DNA data window. So here you can file through the different sequences. You have the GenBank number, the marker type, and sequencer. And if you would like to add even more data like primers, like primer PCR data, or even link your ABI files, this can be done here. For geology, we had to modify, so specify is not, actually was not constructed to hold geological data, but we forced it somehow. So we repurposed some of the fields of the determination table. So we renamed these fields to also to be able to migrate our geological data. This is a temporary solution, but because it's not really advisable to use the same field for different kinds of information. So once the geological modules will also be available for specify, we will have to reorganize the data. Particularly for geology, you have also the paleo context. That means for the stratigraphic data. It's also used in paleontology. If you click on it, you get a floating window with chronostratigraphic data, but also other geological data. The data, let's say for the chronostratigraphy, they come from a Thesaurus, like also the taxonomic and the geographic information. This is presented in a tree-like form, so this is kind of classification. And you can search the single terms. So if you want to enter this age, the Aptian age, you search for this, and all the rest is also automatically filled in. So this is actually the purpose of a thesaurus. So the process, we had to prepare, specify. We modified most field names for our use, the user interfaces, and also the pick lists. We created labels and loan forms. Then exported the data from each FileMaker base to Excel. Then there was an extensive cleaning and homogenization, and also the splitting and preparation so that it can fit into Specify. But not all of the cleaning could be done because it's too labor intensive. Then it was imported into Specify, including also all the linked photos we already had. And this took us about 3 years of intensive work. And currently, there's about 99% of our 500,000 records have been migrated, and we expect to have the last records migrated within the next few weeks. So accessory works that should not be forgotten if you plan similar work to do. So do not underestimate the time it takes. You also have to train the users, which can be very time-consuming. You have to provide a continuous help for the users, so you have to organize this somehow. You need personnel to do this. And, of course, you also have to continue with the fine-tuning and the adapting of the labels, the loan forms, and also the user interface, and also the development of Specify. So you have regularly new versions. So this imposes quite a work. So the next steps would be prepare for the upgrade of Specify 7, which is an internet browser-based version, but which uses the same database. So 6 and 7 can be used in parallel. And then, of course, as I mentioned, implementing a dedicated mineral science edition, which will be discussed maybe later, which is a project of SwissCollNet. And I didn't mention it, but I was made aware by Holger that in the future, of course, we also have to align our data to the Darwin Core standards. So this should have been done earlier, but it wasn't possible, so we have to adapt this later. So that means for all the countries, which are the country names at the moment, they are in French, but there's a field left for the code. So the international code for a country, and all these internationalization of the data, this will be a work that still has to come. The conclusions: migrating our legacy data was much more difficult than I anticipated when we started it, and it was much more time-consuming than I thought. So I thought, yeah, I do this maybe with 25% of my workload. So I do this just as a side project. No, so in the end, I worked almost 100% for it. Adapting Specify the user interface cannot consider all wishes, and so not all of the users were happy with the results. But this is actually the case for any application. So some of them will be more happy, and some of them they will say, no, it was better before. Assistance and help service they are needed, and it should not be underestimated the degree of this if you have a project like this. And also the costs should not be underestimated, right? The costs in salaries, but also you have to be a member and specify. Yeah, if you use another application, you have to pay if it's a commercial product. So the costs are high. And some conclusion, so it's just a detail. It would be better not to have too many separate collections. So if you are able to put together some of your collections, let's say all the invertebrates in one unit, that would be good. So we decided to leave all our collection data in the 14 or 13 different databases or separated units. But now in the end, I would think it would have been better to combine some of them. Despite all the difficulties, the data migration was really needed, and we will be in a much better position for future developments. Okay, that's it.
Thanks very much, Peter. Time for questions.
At the end, you said it would have been better to roof them. I thought one has to roof them in the same system, like all invertebrates in one system to go into specify, or do you have now in specify different topics or different, like?
Yes, yeah, we have actually also specify has a kind of compartmentation. So let's say the mammals are separate from the birds, and the invertebrates, they are split into the lower invertebrates and two groups of arthropods. So this is also a little bit related to the size of the database, but it would be better to have as few as possible.
So you have a table of objects for the birds. You have a table of objects for the mammals. Two separate tables.
Basically, so it's actually in the same database, but the access is restricted. So.
But is it in the same table or not?
It's in the background. It's in the same table, but the access is controlled. So if you log into the mammals database, you see only the mammal data, and also some information like the localities, and so they are actually private for these compartments. So
all mammals objects are in one object table?
Yeah, no, all of them, they are in the same file, but it's only the access which is controlled, and what you see. Yeah.
Thank you. Another question?
A very time-consuming and very expensive process to import the data in Specify. How do you imagine the future? Is it possible to continue to Excel sheet and import them to Specify? Or imagine that each of the user directly write the data in Specify?
Yeah, that's a very good question, and we have a constant fight. So for some reason, so if you already have the data, let's say the external scientists, they identify thousands and thousands of your specimens, and they prefer to hand in these data in an Excel file. Of course, we will import them. And also for some project of the SwissCollNet, because some data were already available, we also decided they have hundreds or even thousands of records, so we will import them later. But this implies always a lot of work. It's much better just to directly register your data in Specify, because then you can profit from all the cleaning that has been done before. So you do not always need to check, this person or this agent has already been entered in the database. what is actually the spelling is correct, what was his first name, and all this. So when you enter data directly in Specify, you have all these controls. You do not introduce unnecessary heterogeneity, because when you import data from Excel, you have all the possible spelling errors or variations, or let's say.
I have one question. I think you didn't mention the public accessibility of the data. Is that something that was also facilitated with Specify?
So there's actually, if you want to share data, you have to export them. And there is an export function for it. It's already actually a template provided for Darwin Core export, but it has only very few of the fields. And every user, every museum has some slightly different usage of the field. So you have to consider this. So you have to, basically you have to make a mapping of your data to the Darwin Core legends or headers of the columns. This is actually available. But this is something not a curator can do, but this needs actually a database administrator to must do this.
Thank you, Peter. I think we need to move forward.